Welcome back. I'm Dr. B. We're doing high adventure science. Will there be enough fresh water? This is on learn.concord.org. We're on activity 6 and we're picking it up on page 4. There is a part 1 video that goes through pages 1 through 3. We're transferring water supplies. Most people live in urban areas rather than rural areas. With more people, there's greater demand for water. The aquifers that run beneath urban areas do not supply enough water to meet the demands, so water is brought in from rural areas. Rural areas are the country, like where there are many farms, and urban areas are cities. What does this do to rural aquifers? Place 2 wells in the rural areas. One is a flowback well. This is the rural water supply. One is a non-flowback well. This water is moved out to the city, away from the aquifer. Step 2, place 1 non-flowback well in the urban area. This water is used within the city. Wastewater from the city is sent to a wastewater treatment plant outside the city. The treated water is released into a waterway near the treatment plant. Run the model for at least 5 minutes. So let's follow the directions here. If we look, we're supposed to put 2 wells in the rural area, 1 flowback and 1 non-flowback. So we can choose the type of well we want right here. Here's the flowback well. Let's put that in the rural area. And then we need to choose a non-flowback well and put that also in the rural area. If you put a well you don't want, you can just remove that well and you can go back here and choose the non-flowback well, which is what we needed here in the rural area or in the urban area. So let's review. We've got 1 flowback well in the rural water supply. That's going to be used probably for irrigation. The water will go out onto the soil and flow back into the aquifer. That's a flowback well. A non-flowback well means this water will be pumped out and sent to the city. In this non-flowback well, the water will be pumped out, used for within the city, and then treated as wastewater and put into a body of water, usually a river, maybe the ocean. We're going to insert a snapshot of the results of our experiment. So we better start our experiment. Let's look at what happens to the water flow at each of these wells. The blue line will be well number 1, the flowback well. The red line will be the non-flowback well in the rural area. And number 3 will be the non-flowback well in the urban area. Look what's already happening to this black line here, which is the non-flowback well in the urban area. What's happening to this aquifer? All the aquifers look like they're being a little bit depleted because we're removing water from this aquifer and we're sending it over to the city. And so it's not being sent back into that aquifer. And eventually that aquifer is going to become depleted because it's not getting recharged with the water that's being pulled out. And you can look at some of the runoff here off the pavement in the city, the impermeable surfaces. If you're having a hard time thinking about impermeable, think about plastic. We can use this to represent blacktop. If you pour water in this plastic takeout container, it's just going to sit there. It's not going to soak through. And that's what happens with sidewalks and roads. So let's stop here, take a snapshot. And I gave you a couple sentence starters. You can talk about the urban aquifer and what you see on the graph, the black line here. And then you can also talk about the rural aquifer and the blue and red lines that go up and down. They're not completely sustainable, but they look like they might have a steadier supply of water than the declining supply of water in the black line or the urban area. So click Done when you're done. You need to fill out the blanks, of course. In the model, what happens to the water removed from a flowback well? So let's run this a little bit. Number one's a flowback well, and we can see kind of water spurting out from the flowback well, and it just goes back onto the soil around the aquifer. That's what happens when you use a flowback well for irrigation, or use it for a private residence out in the country that has a septic system. That water eventually gets returned to the aquifer. What determines whether surface water can recharge an aquifer? The type of well, the porosity of the underlying sediments, the permeability of the underlying sediments, the amount of water in the aquifer, the amount of precipitation. Well, think about what's going on in the city here. What do we see on the top of this aquifer here? We talked about impermeable surfaces. We talked about a takeout container as an impermeable surface, and water can't go through this plastic black takeout container, nor can it go through blacktop that's on our streets or roads. And we have similar surfaces on our rooftops. Sustainable water use occurs when the withdrawals of water are equal to or less than the inputs of water. Which of the wells in this model showed sustainable water use? The rural flowback well, rural well pumped to the city, urban well treated at a wastewater plant, and then that wastewater is sent to another body of surface water, rural flowback well and urban well treated at wastewater plant, rural flowback well and rural well pumped to the city, rural well pumped to the city and urban well treated at wastewater plant. Think about which aquifer is getting recharged, and then explain your answer. If you want to explain how certain you are about your claim based on your explanation, I will give you some words to think about to include in your explanation. So I've given you a few hints. The most sustainable model is because water is returned to the aquifer. Water pumped out is balanced by, which recharges the aquifer. My explanation is based on balance. If a system is sustainable, the outputs need to be balanced by, in an urban area, impermeable surfaces prevent, wastewater does not what? The aquifer, because it's put in surface water. When you're done filling in the blanks or writing your own sentences, hit submit and see how Hasbot will give you feedback on what you might have missed or what you could add to make your answer better. So, for example, can you provide specific evidence from the model about the water level at the bottom of each well? Or what factors of the wells and surfaces affect the recharge of the aquifers below? Always try to improve your answer from Hasbot. Now think about the potential weaknesses of the argument. Are there limitations to models of wells and water movement in urban and rural areas? What are they? Well, it's a model. All models have imperfections. They're not reality. We don't know what's going on underground. And that's what I would add to my answer. Transferring water waste. You just used a model to show what happens to local aquifers when water is pumped from one area to another. This is called interbasin transfer because water is moved from one aquifer to another. In the model, water was pumped from the rural area's aquifer to the urban area, but it didn't go into the urban area's aquifer. Why not? Most urban areas have wastewater treatment plants that discharge treated water into yet another water basin. The diagram gives an overview of parts in a large wastewater treatment plant. The wastewater from homes and businesses is treated to remove solids and nutrients. Then it is disinfected and discharged into a nearby stream, river, or ocean. The water may then flow away from the aquifer from which it was drawn. So wastewater is all the things that run down the pipes in your house. So water that goes out of your sink in your bathroom and your kitchen. Water that goes down the drain in the shower. Anything that you flush. Your laundry water. All that is wastewater. And it goes into a series of sedimentation and digestion. The digestion gets all the organic solids out of it. And then there's filters and aeration and clarifying. It sits in oxidation ponds. You may have seen this at a sewage treatment plant or wastewater treatment plant in your community. And then it can go to the ocean. It can go to a river. Maybe it goes to a big lake. How could you use the treated wastewater to recharge the aquifer? Describe the path that treated wastewater would take to recharge the local aquifer. Well, if you pumped it out over here, you could pump it back to over here and use it to irrigate agricultural fields. You could spray it into a forest and let it sit on the forest and soak in. There might be a lot of ways. You could let it sit in a pond or a lake over where you took it out, and slowly it would trickle into the groundwater. So think about creative solutions that you could use wastewater for, where it would start to recharge the groundwater. Here are some ideas that could lead to your creative solution for how we could use treated wastewater to recharge the aquifer. Think about what infiltration means, water seeping back into an aquifer. Infiltration recharges the aquifer, filling it up with water again. You can use ponds or wetlands to help water slow down and infiltrate into the aquifer. Beavers are very good at making these ponds in natural streams, and we could do something similar with ponds or wetlands with this wastewater. We have to think about evaporation when we think about using wastewater for irrigation. A lot of that wastewater, when we irrigate with wastewater, doesn't make it back into the soil. It's just evaporated. We have to be careful with our irrigation water if we actually want to make it back into the aquifer. You can think up other interesting and creative solutions and put it there for question 23. In contrast to urban areas, many rural areas have local wells drawing water from a local aquifer and local recharge, as the wastewater is treated in local septic tanks, usually right around your house. The diagram shows how water used in-house is returned to the water table through percolation from a septic system's drain field, also known as a leaching field. So we have a well, it's bringing up water, it's bringing it to the house. The house's wastewater goes to a septic tank, and eventually that wastewater is returned to the aquifer because it's allowed to kind of spread out and soak in. All the solids are digested with bacteria here, and hopefully pretty clean water is sent out here to percolate back into the soil. As you might recall from the first activity in this module, the main problem regarding water distribution is the mismatch between where the rain falls and where people live and grow crops. Transferring water from one location to another has contributed to freshwater availability issues. The question of whether there will be enough fresh water for the future hinges on the decisions that people make about their water use. You are important in making good decisions. Use what you've learned to generate a possible solution to the problem below. A large city is supplied with water from lakes and reservoirs in rural areas surrounding the city. The city's wastewater is treated at a large wastewater plant 10 miles away, where it is discharged into a river that flows directly into the ocean. The city's population and water demand have grown recently, and they have developed a plan to drill wells in other communities around the city. Now, if I lived in one of those other communities, I'd be kind of mad. People living outside the city get their water from wells drilled locally, and they discharge their treated water locally. Water is used in the rural areas for both domestic and agricultural uses as farmers irrigate their crops during the hot, dry summers. People in the rural areas are concerned that their water supply will be affected if the city increases its water withdrawals. If their water supply is affected, they fear that they will not be able to grow as much food and their income will suffer. Because people who farm, if they don't have water and they're not able to grow crops, they've lost their income, they've lost their job. Based on what you know about water flow, how would you solve this problem? What factors do you need to consider to make a decision? Who should get to use the water? Okay, now it's your turn. Here are some things to consider. Water is pumped out of aquifers outside the city. After it's used in the city, it's put in a river that flows to the ocean and not returned to the aquifer it came from. So, questions you might want to consider in who gets to use the water or how you could fix the problem is who is returning the water to their own aquifer? How could more water be returned to the aquifer it came from? You have to use what you've learned to answer these questions and solve the community's problems. Real communities have these issues, and you can't solve the problem, but you can think about what sorts of problems occur and how you might speak out in your own community about conserving water and protecting groundwater. Thanks so much for working with me. You've been awesome. I will see you next time on the next High Adventure Science activity.